Scaffolds, or temporary work platforms, can provide a safe and more efficient way to work in construction. But the use of scaffolds is also one of the leading causes of injuries on construction sites. Unsafe scaffolding causes an estimated 3,000 injuries and 79 work-related deaths a year. And workers being exposed to hazards on scaffolds is one of the most common OSHA violations. It's important to recognize scaffolding hazards and make sure every scaffold is set up and used properly. Although there are many different types of scaffolding, there are several common hazards associated with all types of scaffolds. Number 1, falls due to lack of fall protection. 2, unsafe access due to ladders, stairs, and ramps. 3, injuries from falling tools, work materials, or debris. 4, electrocution due to the proximity to overhead power lines. And 5, collapse caused by instability or overloading. There are requirements specific to scaffold erectors and to scaffold users. Erectors have to use a combination of fall protection methods, which include body harness, lanyards, and vertical and horizontal lifelines. Users must be protected against falls by guardrails, full decks, and safe access, and knowing when they would need other forms of fall protection. Any scaffold 10 feet high or higher and more than 14 inches away from a building must have a complete guardrail system with toe boards covering all exposed sides and ends. The top rail must be 42 inches high, the mid-rail 21 inches high, and the toe board must be at least 3.5 inches high, or as high as the material on the scaffold, to prevent objects from falling off. If guardrails can't be used, workers must use a personal fall arrest system when the scaffold height is over 10 feet. Falls from scaffolds generally occur when personnel are climbing or descending the scaffold. In many cases, injuries occur when climbing the braces or scaffold frame that was not designed to climb. Safe access to the scaffold work area is required when the elevation change is more than 2 feet. Equipment that can be used for safe access could include secured ladders, clamp-on ladders, and built-in ladders. You can directly access scaffolding from another scaffold or structure, provided it is not more than 14 inches horizontally and 24 inches vertically from the other surface. Cross braces cannot be used to climb on or off the scaffold. Being struck by falling objects is a common occurrence that can be reduced or eliminated by using toe boards, netting, or by barricading the area. It's important to note that hard hats must be worn at all times when working on and near scaffolding. Overhead power lines can be extremely dangerous, even deadly. Scaffolding should be built at least 10 feet away from an exposed power source, unless it has been insulated or de-energized. All electrical tools and power cords must be in good condition and protected by a ground fault circuit interrupter device, or GFCI. Do not work on scaffolds during electrical storms or high winds. Scaffolding collapse can be caused by several factors, including poor foundation or footing, improper construction, overloading, and being struck by machinery. Always know the foundation the scaffold will be built on. Never build scaffolding on stacked bricks, block, or other unstable objects. All scaffolds require steel base plates, adjustable bases, or casters. Mud sills can be used under the base plate to spread the load when scaffolds are built on soil or asphalt. If using mud sills, ensure the base plate is nailed to the mud sill to prevent displacement. It's important to know what the load capacity is of the scaffold to avoid collapse. A scaffold must be able to support its own weight and at least 4 times the intended load, which includes workers, tools, equipment, and materials. Bracing is extremely important. Scaffolds should never be used unless all required bracing and securement is in place. Scaffold platforms must be fully decked and at least 18 inches wide. Only scaffold-grade planks should be used. Planking can be wood, metal, or a combination, and must be secured to prevent movement. Workers who are involved in using, erecting, or disassembling scaffolds must be provided training by a competent trainer who can identify scaffold hazards and has the authority to correct or eliminate them. This person should also be responsible for overseeing the setup, dismantling, or any modification of any scaffold, and is required to inspect scaffolds and scaffold components for visible defects before each work shift. By following these safety guidelines, scaffolds can provide you with an efficient work site while maintaining the well-being and protection of you and your crew. While many workers are exposed to electricity as part of their daily responsibilities, electrical hazards present a unique challenge in construction, as electricity is an unseen hazard, and many workers are unaware of the risks and hazards present in their workplace. In addition, due to the dangerous nature of electricity, most incidents resulting from electrical hazards can often be life-altering or fatal. It's important to understand and recognize the top risks and hazards involved with working with or around electricity, and the proper techniques to mitigate and control these hazards. The most common causes of electrical incidents and injuries come from the following: contact with overhead or buried power lines and other live parts, lack of or improper ground fault protection, grounding paths missing or discontinuous, improper use of extension cords and equipment, working on energized or hot electrical circuits. The main types of electrical injuries are burns, electrocution, which is always fatal, falls resulting from contact with electrical energy, and electric shock. Overhead or buried power lines are especially dangerous to workers because they contain very high voltage and are typically uninsulated. Contact with these lines are typically fatal. The most common cause of contact with power lines comes from the use of equipment, including cranes, backhoes, metal ladders, raised rough terrain forklifts, aerial lifts, metal building material, concrete pump trucks, raised dump truck beds, and scaffolding. It's important as a worker to do a visual survey of the work area and look for any overhead power lines or buried power lines before starting work. Before digging, call 811 Miss Utility to help identify the exact location of underground utilities that will be marked with flags or painted marks. You must always assume that overhead power lines are energized, so you must maintain at least a 10 feet clearance at all times. Missing switch plates or receptacle covers around electrical outlets and missing covers on breaker boxes can lead to workers being exposed to live electrical parts and inadvertently making contact with it. So receptacle and switch covers must always be installed when there is live power to the outlets. Normal use of electrical equipment on construction sites causes wear and tear that can lead to exposed wires and damaged insulation and short-circuiting. Without proper GFCI protection, any of these conditions can lead to a ground fault sending electrical current through a worker's body, causing electrical burns, fires, explosion, shock, or electrocution. To avoid these hazards, use GFCI protection on 120 volt, 15 and 20 amp receptacles. Use double insulated or properly grounded tools and equipment, and follow manufacturer's instructions on proper usage. And always inspect all equipment and tools before use, and remove from service any tool with frayed, damaged cords, missing ground pins, and damaged or cracked tool casings. Most electrical tools and equipment have safety. energized live parts while working on or near them can be extremely dangerous. Never work on energized or hot electrical circuits until all power is shut off or de-energized and a lockout-tagout system is in place, which protect workers from the dangers of the accidental or unexpected startup of electrical equipment. If the work can only be performed on live energized equipment, an electrical hazard analysis must be conducted, and safety-related work practices outlined in National Fire Protection Association 70E must be followed. Following these practices will keep you working safely. In this video, we will discuss best practices for ladder use and give you tips to keep you safe on every job. Having the right ladder for the job is the safest way to complete any task. So how do you ensure you are choosing the right ladder? It's important to understand the differences between ladders, including their function, ratings, and materials. First, you should select the style that best fits your job. There are 5 basic categories of ladders: step, extension, multi-use, podium, or job made. A step ladder is a portable, self-supporting A-frame ladder. An extension ladder is also referred to as a portable ladder, but they usually have 2 sections that operate in brackets, allowing for adjustable lengths. Multi-use ladders have the capability to be set up in a variety of configurations. Podium ladders are self-supporting A-frame ladders that provide a large, standing surface, allowing workers to face any direction without needing to reposition the ladder. And the last category is job-made ladders, constructed on-site, usually out of wood to fit very specific needs. To decide which type best fits your task, you need to determine the following. For what jobs will you need the ladder? Will the ladder be used inside or outside? What heights will you need to reach? How much weight will be on the ladder, including tools and materials? And is there a possibility of working near electricity or power lines? A ladder duty rating determines the load capacity or maximum weight the ladder can safely support. Calculate the workload, include the approximate weight of the worker, the tools needed, and the materials that will be used to complete the job. Then determine heights you will need to reach to complete the task. The maximum safe reaching height is approximately 4 feet higher than the height of the ladder. For example, if you needed to reach a 10-foot ceiling, you could safely use a 6-foot ladder. Finally, you should consider the materials used to construct the ladder, typically wood, aluminum, or fiberglass. Harsh conditions or specific chemicals will affect your choice of ladder. For example, if you're working around electricity or power lines, you need to choose a non-conductive material such as wood or fiberglass. Ladders are like any other tools on the job site. They must be protected from physical damage and kept in good working condition to ensure your work can be done safely and effectively. Before every use, you should perform a visual inspection of the ladder. First, check for missing or damaged feet. Ladders may have either non-skid pads for use on hard surfaces such as concrete and flooring, or metal feet for soft surfaces such as dirt and gravel. Next, check the side rails and rungs. Look for broken, slit, cracked, corroded, bent, or missing rails and rungs. Finally, check for any loose, corroded, or weakened hardware like bolts, rivets, fasteners, or latches. Defective or damaged ladders must be immediately tagged as defective and removed from service. Regularly inspecting and maintaining your ladder will extend the life of the ladder and help ensure your work will be done safely. When handling and setting up a ladder, always be aware of your environment and look for potential hazards or obstacles that could put you in an unsafe position. When carrying a ladder, grasp the rail toward the center to create a balanced load, and have a coworker help you carry long or heavy ladders, and also be cautious carrying a ladder through tight spaces. Always be aware of electrical lines and maintain a safe distance of at least 10 feet. When using a step ladder, open the ladder so that the spreader bar is completely horizontal and locked. Then check that all 4 feet are balanced and have secure footing. Never use a step ladder in a closed and leaning position. To properly set up an extension ladder, you should place the ladder at a 4-to-1 angle against its point of contact. Then you'll need to secure it at the bottom or the top to prevent any sideways movement. Ensure that both feet are balanced and have secure footing. You should use a ladder leveler when working on uneven surfaces. If you're on a hard surface, you should use the non-skid or rubber feet. But on a soft surface like dirt or gravel, you need to use the metal feet and dig them into the ground to secure the ladder. When using the extension ladder for access, make sure the rails extend at least 3 feet above the landing surface or access point. Proper ladder setup not only helps prevent injuries, but aids in the efficiency of the task at hand. Falls from ladders are one of the leading causes of fatalities and injuries on construction work sites. Here are a few reminders and tips to keep you working safely. First, always read and follow the ladder safety instructions and load ratings. These instructions are usually located on the side rails. When climbing and working on a ladder, you should always maintain 3 points of contact, such as 2 hands and 1 foot, to prevent slips or falls. Don't overreach. The maximum reaching distance is about 4 feet above the height of the ladder. On an extension ladder, the highest standing level is 4 rungs down from the top, and on a step ladder, it's 2 rungs down from the top. Never set up a ladder in a high-traffic area where other workers or machinery could bump or knock down the ladder. Never place a ladder upon other objects, such as boxes, or barrels, scaffolds, or other unstable bases, in order to obtain additional height. And never use improvised or homemade ladders, or carry out makeshift repairs to a damaged ladder. Proper setup, use, and maintenance of your ladders will ensure a safe workplace and prevent serious injuries.